Welcome back to the Java interview preparation course where we will cover data structures and algorithms in Java. First, let's see about what is data structures. A data structure is a way of organizing and storing data efficiently for easy access and modification. There are two types of data structures. One is linear data structures, another one is non-linear data structures. Under linear data structure, we are having array, linked list, stack and queue. And under non-linear data structure, we are having tree, graph and hash tables. Let's see what are those things. Array has a fixed size collection of elements stored in contiguous memory. That means continuous memory. Okay. Example, used to store product categories in an e-commerce system. At the time, we can use array for storing the product. Next, linked list, a dynamic data structure where elements are connected using pointers. So that pointer connect the elements. Example, where we can use this linked list used for implementing a shopping cart where items can be added or removed dynamically. While I'm adding the product, it will add product to the linked list. If I'm removing it, it will automatically gets removed. So we can use it there. And next, see stack. Stack means it follows the last in first out principle. So it will add the data last, and if we are going to delete that, first element first gets removed. Okay, and then let's see about queue. Follows first in first out principle. That means if you are adding or deleting, it will give the first preference to the first element. Okay, example where we can use this processing orders in an online food delivery system. So online food delivery system, so the first order we will place it first try. So there we are using this one. So for stack, example we can have it undo redo features. So that one means last one. I mean in the notepad, if you are typing something, if you use the undo function, it will remove the latest changes you did. So like that, stack will remove the last added element. Okay. Then next, learn about non-linear data structures. Tree. So this tree, a hierarchical structure where each node has a parent and child nodes. Okay, so tree means it's a node, and that node, how it works now, parent has a child node, like that it's linked. And where we can use tree in e-commerce product, while organizing the product categories, we can use it. And next, graph. Graph means a collection of nodes connected by the edges, used for relationships and networks. Finding the shortest delivery route using register algorithm. So this is the example, real-time example for graph. And hash table. Hash table means key value pair. So key value based data structure for fast lookups. So for example, hashing frequently searched products. So frequently searched products, so we can able to store it in hashing and show it to the user, right? So at the time we can have it hash table. Let's learn about algorithms. An algorithm is a step-by-step procedure for solving problem efficiently. There are different types of algorithms available. First, let's see about sorting algorithms. First one, bubble sort. What it does, repeatedly swaps adjacent elements if they are in a wrong order. So it will produce the sorting function. Example, not efficient for large data set. Actually, number of order is it's taking number of times too much, right? So it is not suitable for the large data sets. Next one, merge sort. A divide and conquer algorithm that splits the array and merges sorted parts. And so O n log n times it will divide and conquer the algorithm. So merge sort means there is one number of array, I need to sort it, means it will divide half and sort it based on that. So for example, in a e-commerce, sorting products by price efficiently, like that. Next, quick sort. Similar to merge sort, but uses a pivot for partitioning. So there is a point for partition. So here O n log n, this number of times will take it will take time for sorting. And sorting custom reviews based ratings. This is the example for quick sort. And searching algorithms. Linear search. So it checks each element one by one. So linear means it's a order, so it check one by one, number of times it check. An example where we are using this, searching for a product in an unordered list. Next, binary search. Works on shorter data, dividing the search space in half. So this is a log n number of times it will work. Example, searching for a product in a shorted catalog. Okay, linear search is for unordered list, and this binary search for shorted catalog. So this is easy, right? Easy to find. That's it. Graph algorithms. So there is BFS, breadth first search. It explores all neighbors first. Example, finding the shortest delivery route. Okay. And DFS, depth first search. It explores deep paths first before backtracking. So where we can use it, depth first search, finding all possible product recommendations. So we will see all possible recommendation, and that's it. Let's see about most commonly asked interview questions in data structures. What is the difference between an array and linked list? This is question number 1. You can answer like, an array has a fixed size and allows random access, whereas a linked list has a dynamic size and allows efficient insertion and deletions. In an e-commerce system, an array can store product categories, while a linked list can manage dynamic items in a shopping cart. Question number 2. How does quick sort work and why is it preferred over bubble sort? You can answer like this. Quick sort is a divide and conquer algorithm that partitions the array using a pivot and sorts both halves recursively. It is preferred over bubble sort due to its number of log n and number of times multiplication, so average cache time complexity, making it much faster for large data sets. And question number 3. Explain the difference between BFS and DFS. You can answer like this. BFS, breadth first search, explores all neighbors first and is useful for shortest paths problems like delivery routes. DFS goes deeper into branch before backtracking and is efficient for graph, traversal and recommendation systems. Question number 4. What is the difference between hash map and tree map? Hash map provides fast lookups with number of 1 complexity, but tree map maintains shorter order with log n complexity, O of log n complexity. So hash map is used for hashing, while tree map is used for ranking shorted leaderboards. So mastering data structures and algorithm is key to passing a Java interviews. So these concepts are valued in real world application and will help you write efficient and maintainable and high performance code. Keep practicing coding problems, apply these concepts in Java and head ready to ace your interview. If you are preparing for a Java developer interview but don't know where or how to start, or maybe you are already working and want to level up your Java skills with a real-time project, well, I have got something perfect just for you. I have created a complete Java interview preparation course where we don't just learn theory. We actually build a real-time project, a bank customer management system using Java, Spring Boot, Hibernate, JPA, MySQL and microservices. Yes, it's the kind of project you would work on in a real company. Inside this course, you will learn Java OOPS concepts with real-time code, REST APIs with Spring Boot, working with databases using JPA and Hibernate, SQL queries, GTL, DML, DQL and more. Real-time coding scenarios that interviewer ask about. Whether you are a fresher or experienced developer, this course is tailor-made to help you crack interviews and improve your on-the job skills. Drop a Java in the comments if you are excited to start and let me know what Java topics you want me to cover next. Don't forget to like, share and subscribe if this helped you and tag your friends who is preparing for Java interviews. Thanks for watching.